Welcome to Part 1 of the GCP Fundamentals Complete Study Guide, the series that takes you from zero to hired in Google Cloud. If you've watched any of the earlier parts, you already know the drill. No fluff, just real, actionable knowledge that moves your career forward. Now, let's kill the cliché right away. The cloud is just someone else's computer is the lazy take. The truth is, cloud computing is like the power grid. You don't build your own generator, you plug into a utility and pay only for what you use. Cloud computing shifts IT from a capital expense to a variable operating cost. You spin up resources when needed, and you pay only for the time you use them. This shift from massive capital expense to a variable operating cost is what makes the cloud so powerful. Your actionable step this week: head to console.cloud.google.com and sign up for the free trial. You can use a Google account or a Microsoft account via single sign-on. Activate the trial, check the current credit amount, to get 90 days of hands-on learning with no upfront commitment. By the end of this series, you'll have the practical skills that separate hired cloud engineers from hobbyists. Think of the National Institute of Standards and Technology, NIST, definition of cloud computing. On-demand, convenient, pay-as-you-go access to a shared pool of configurable resources, servers, storage, networking, services. That's exactly how a power grid works. You don't own a coal plant, you flip a switch. With GCP, you request a virtual machine, a database, or a Kubernetes cluster. That's a managed set of containers orchestrated by Kubernetes to run your applications. And Google's massive private fiber network delivers it in seconds. And here's the kicker: Google bills by the second. So if you spin up a VM for 15 minutes, you pay for 15 minutes, not a full hour. That kind of granularity means you can experiment, run batch jobs, or auto-scale without wasting money on idle time. Think about the financial shift. Traditional on-prem infrastructure requires a hefty upfront investment in hardware, plus ongoing power and cooling costs. In the cloud, you typically pay nothing upfront. You rent compute by the second or hour and stop paying when you stop using it. This transforms a fixed capital expense into a flexible operating expense. You can scale instantly when your app goes viral without begging for budget, and kill resources just as fast when demand drops. Infrastructure becomes a variable cost you control. Here's the part almost everyone gets wrong. Simply moving to the cloud does not automatically save money. In fact, it can cost you more if you mismanage it. The classic rookie mistakes: leaving test VMs running over the weekend, forgetting to cap BigQuery queries, or deploying a cluster without setting billing alerts. Cloud gives you unlimited power, but it also gives you unlimited bills. Don't worry. Later in this series, we'll dig deep into GCP's cost management toolkit, including budgets, quotas, and cost tables. For now, just know: treat every resource you create as if it's ticking up a meter. Time to lock in what you just learned. Here's a quick checkpoint. If a VM costs $0.05 per hour, what do you pay for 15 minutes of use in GCP? The answer is not $0.05. Because GCP bills by the second, you pay only for the time you actually use. 15 minutes is about 1.25 cents. This is a huge advantage over providers that bill by the hour, where a 15-minute job still costs you a full hour. In GCP, your experimental workloads, every short burst, gets charged accurately. Cloud services are typically stacked into a pyramid. At the base, IaaS, infrastructure as a service, gives you raw virtual machines like compute engine. You manage the OS and runtime, Google manages the hardware. Move up to PaaS, Platform as a Service. App Engine lets you deploy code and forget about servers. Next, Cloud Run, Google's fully managed container platform. You provide a container image and it handles scaling for you. FaaS, Cloud Functions, is pure serverless. You write a function, Google runs it. At the top, SaaS, Software as a Service, like Google Workspace, you just use the application. The higher up the pyramid, the less you manage and the more Google does. With IaaS and Compute Engine, you get the steering wheel. You choose the operating system, the exact memory, the CPU count. Google provides the physical infrastructure and the global network. This is the model you use for lift and shift migrations, like taking a legacy .NET app running on Windows Server 2019 with a very specific configuration and moving it to the cloud without rewriting anything. You handle patches, security updates, and software installation, but you also get complete control. Now contrast IaaS with PaaS. On the left, Compute Engine means you're patching OS, installing web servers, configuring auto-scaling groups. On the right, App Engine. You literally push your application code, and Google handles the rest. No server administration, no scaling configs. App Engine can scale from 0 to handle high traffic loads without manual tweaking. For most new applications, this is where you want to be. At the top of the pyramid, two models make the server disappear completely. SaaS, like Google Workspace, Gmail, Drive, Docs, you just open your browser and work. No setup, no backups, no maintenance. FaaS, like Cloud Functions, is what we call serverless compute. You write a snippet of code, say to resize an image when it hits cloud storage, and Google runs it in an ephemeral environment. You manage nothing but your code logic. The provider handles everything else, just like your electricity utility. Containers as a Service sits between IaaS and pure PaaS. You package your app into a container image, and Cloud Run takes it from there. It automatically scales up and down based on traffic, even to 0. You never see a virtual machine. If you need full orchestration, multiple services, service discovery, rolling updates, Google Kubernetes Engine, GKE, gives you all the power of Kubernetes without the operational overhead of managing the control plane. This is the sweet spot for modern microservices. Quick check. You need a custom Windows Server image, full admin, no guardrails. Which service hands you the keys? Pause and think. Thumb. It's Compute Engine. IaaS means you own the OS. App Engine and Cloud Run abstract it away so they can't give you raw control. A cloud isn't one size fits all. Public cloud, like GCP, is Google's infrastructure. Private cloud is your own data center. Hybrid links them together, often through Cloud Interconnect and Anthos. Cloud Interconnect is GCP's dedicated high-speed connection between your on-premises network and Google's network, making hybrid truly seamless. Multi-cloud layers in a second public provider, like running GCP and AWS side by side. Anthos is GCP's Swiss Army knife for managing all these in a single pane. Anthos is Google's answer to the enterprise nightmare of managing clusters everywhere, your rack, GCP, even AWS. It gives you one Kubernetes dashboard, one policy engine, one way to deploy. That's why banks and retailers trust it for hybrid. We'll unpack Anthos in detail later in this series, but for now, just know. It's the bridge between your world and Google's. GCP didn't start as a cloud platform. It began as Google's internal tooling. Early research papers on distributed file systems, MapReduce, and scalable databases laid the big data foundation. App Engine, introduced early on, opened the platform to external developers. Compute Engine later brought IaaS capabilities directly to enterprises. The release of Kubernetes transformed container orchestration across the industry. Under new leadership, Google Cloud evolved into a profitable enterprise-grade platform. Today, it spans dozens of regions worldwide, delivering AI-powered services on the same global backbone that runs search and YouTube. Kubernetes traces its DNA back to Google's internal cluster manager, Borg, the system that powers search, Gmail, and Maps. In 2014, Google released Kubernetes as an open-source project based on those lessons, but it's a new tool, not Borg itself. That's why GKE feels so mature. Google's been running containers at planetary scale for over a decade. Among the top 3 cloud providers, each has a distinct superpower. AWS brings the broadest service catalog. Azure is woven into Microsoft's enterprise fabric, and where GCP truly excels is data analytics and AI. BigQuery and Vertex AI are where GCP punches way above its weight. If your future job is data-focused, GCP is the sharpest arrow in your quiver. But here's what nobody tells you at the start. The timelines and market shares are interesting, but they don't land the job. BigQuery does. It scans petabytes of data in minutes, turning raw logs into business answers before your coffee gets cold. In a moment, we'll return to the foundational concepts, but keep this in mind. Every project, every CLI command you learn is in service of that data superpower. Which GCP service can scan petabytes of data in minutes? Signs. BigQuery. It turns raw logs into business answers almost instantly. Keep that name in mind. It's one of GCP's greatest strengths. Every single resource you create, VMs, storage buckets, BigQuery datasets, must live inside a project. A project is the unit of billing. Every cent gets tied to a project. It's also the security boundary. IAM roles are scoped to projects. Think of it as the container that holds cost, permissions, and APIs together. No project, no resources. A project has 3 identities, and they trip people up. The project ID is the one you pick. Globally unique and can't be changed, so bake in the environment. The project name is just a display name. You can update it whenever you need. And the project number is Google's internal identifier used for tracking and billing. Tip: always include the environment right in the ID. Prod Analytics 01 saves you from accidentally running a test on live data. In GCP, just because a service exists doesn't mean you can use it. You have to explicitly enable the API for each project. Compute Engine, BigQuery, all of them. This isn't a bug. It's a security feature that stops accidental sprawl. But it's the #1 beginner stumbling block. Open the console, go to APIs and Services, and flip the switch before you type that gcloud command. But here's what nobody tells you. The most powerful tool in GCP isn't the console, it's the terminal. The gcloud CLI is how you'll automate everything, enforce consistency, and avoid clicking through 100 screens. It ships as part of the Google Cloud SDK and is pre-installed in Cloud Shell. First, always verify your active project with gcloud config get value project. You don't want to accidentally provision resources in the wrong project. Then, gcloud compute regions list shows every region GCP offers. And to drill into a specific region, gcloud compute zones list with the filter flag gives you only the zones you care about. For example, to see US Central, you'd use a filter like region central 1. The exact syntax may vary, so verify with the current docs. Mastering this is step 1 to working like a real cloud engineer. Quick checkpoint. What gcloud command displays your currently active project? The answer is gcloud config getValueProject. It prints the project ID that all subsequent commands will target. One of the biggest barriers for newcomers is setting up a local development environment. GCP eliminates that with Cloud Shell, a browser-based terminal that runs a tiny free VM right inside the console. Click the terminal icon in the top right corner, wait a few seconds, and you have a fully configured shell with gcloud, Python, and all the SDKs pre-installed. The home directory is persistent, so your scripts and configurations survive between sessions. We'll use Cloud Shell throughout this entire study guide. No downloads, no headaches. The GCP console can feel overwhelming at first, but its structure is actually logical once you learn the mental map. Click the hamburger menu, and you'll see categories like compute, storage, networking, big data, and AI, each grouping the related services. Hover over Compute to reveal Google Compute Engine, GKE, App Engine, and Cloud Run. Scroll down to Big Data to find BigQuery, Dataproc, and Dataflow. This mental model, built early, means you won't waste time searching for services mid-lab. It's the difference between fumbling and flowing. Let's ground this in the real world. When a large media platform needs to handle billions of daily streams, they'd turn to Google Cloud Services. The data pipeline. Every user stream flows into event ingestion, then into BigQuery for real-time analytics. Vertex AI trains machine learning models that power personalized recommendations. GKE serves hundreds of microservices, delivering low-latency audio globally through Google's private backbone. This diagram isn't just a concept. It's a blueprint of the exact skills top employers want you to master. Many organizations choose GCP for 3 key strengths that map directly to these services. First, BigQuery for serverless analytics that can handle petabyte-scale data without managing clusters. Second, Kubernetes Engine, built on Google's deep expertise in container orchestration to scale microservices effortlessly. Third, Google's private global network for fast, reliable content delivery. These aren't just talking points, they're the skills that make you hireable. Now it's your turn. Navigate to console.cloud.google.com and click Get Started for free. Google provides a free trial credit that lasts for 90 days, a perfect playground for this entire study guide. Enter your payment details. A credit card or bank account is typically required for identity verification, and you won't be charged unless you manually upgrade. Accept the terms, and you're in. This one setup step opens the door to every lab and project you'll build. Time for your first real gcloud commands. Open Cloud Shell and type gcloud config getValueProject. The output should show the project you just created. Next, gcloud compute regions list to see all available locations. Finally, gcloud compute zones list. This lists all zones globally. You can restrict to a region like central 1 using the filter flag. The exact syntax may vary, so check the current documentation. This is your zero installation lab environment. Pause this video, run these commands now, and prove to yourself that you're already operating in the cloud. One last checkpoint. What flag did we use with gcloud compute zones list to get only the zones in central 1? The faun filter flag. That lets you narrow down any gcloud list command.